what they are talking about. This is a bag, two bags are available to us. From the two bags, randomly one bag is selected. Out of that bag, again a ball is drawn, and you want to find the probability such that the ball so drawn is white. Again, the question again in nutshell, two bags, different compositions of black and white balls, and first a bag is selected, and after the selection of bag, a ball is drawn. You want the ball to be what? White ball. Okay. Now, how this relates to the total probability theorem, one should see. How this relates to total probability theorem? Drawing up a white ball is an event. It is happening in conjunction with two other events. What are those two other events? Selecting of ball 1, bag 1, or selecting of bag 2. And note that the selection of the bags are exclusive events and also exhaustive events. So, A is an event of drawing a white ball. Drawing a white ball. Now, E1 selection of what? Bag 1. Selection of bag 1. Selection of bag 1. E2 selection of bag 2. Right? Now, probability of A is equal to probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Okay? Now, here there are only two events. That's why the summation is extended up to two events. Now, what is the composition of the bag? First bag, 4 white and 2 black. Now, what is the composition of the bag 2? 3 white and 4 black. Right. So, probability of even any one bag selected is half. Probability of white ball drawn when bag 1 is selected, that is nothing but 4 by 6. 4 white balls, total exhaustive balls are 6. Now, second one, what is the probability of selecting the second bag? That is also half. And once the second bag is selected, what is the probability of a white ball being coming out of it? That is 3 by 7. 3 by 7. Right? 4, 2. Now, next 2 simplification here. So, 2 again will go 1 by 3. 1 by 3 plus 3 by 14. So, this is LCM going to be 42. 42 and 14 plus 9. So, 23 by 42. 23 by 42 is the probability of a white ball being drawn whenever any one bag is selected. This is a direct application of total probability theorem. We will see one more question on total probability of theorem. There are 3 black and 4 white balls in one bag. One bag. Let us call it as bag 1. It contains 3 black, 4 white, bag 1, and second bag, bag 2. Bag 2 contains what? 4 black, 3 white. Now, a die is rolled. Yes. First bag is selected. if first bag selected if 1 or 3, otherwise bag 2 is selected. Bag 2 is selected. Find the probability. Find the probability. Find the probability of drawing a white ball. Yes, this is a question. Now see here. White ball can come from which bag? Either of the bags. So ultimately you want a white ball to be drawn. A white ball to be drawn. So the white ball can come from the first bag. First bag, what is the probability of coming up with white ball? That is 4 by 7. And what is the probability of white ball coming in case of the second one? That is 3 by 7. But in order the first bag to be selected, you should arrive at 1 or 3 when the dice is rolled. 1 or 3 dice is rolled, probability is 2 by 6. When a dice rolled, there are how many exhaustive cases? 6 exhaustive cases, and you have 1 or 3, 2 favorable cases, 2 by 6, and this becomes 4 by 6. So probability of a white ball is nothing but probability of 2 or 3 coming into probability of first bag plus probability of 1, 4, 5, 6 coming, yes, into probability of second bag containing drawing up with white ball. So this we have to simplify now. 6 7 are 42 common, 4 2 are 8 then plus 12, so that is 20 by 42, that is 10 by 21. This is the probability of a white ball being drawn. One of the important important theorem, what is known as Bayes theorem. This is asked in March 2012 as an essay question. Yes, whenever Bayes theorem is given, you should first state and draw and prove what? State and prove what? The total probability theorem. Okay, already we have seen in the beginning what is the total probability theorem. You should first state and prove total probability theorem, proof of it. But first let us see the theorem statement, Bayes theorem statement. What is the Bayes theorem statements? If A1, A2, A3, so on, AN are mutually exclusive, exhaustive events, E is an event such that probability of E is greater than 0, then probability of AK given E is equal to probability of E given into probability of E given AK by sigma probability of E given probability of E into E given AK, K ranges 1 to n. This is the Bayes theorem statement. Okay. Now this Bayes theorem statement, if you see one more time, this one event E can happen in conjecture with any of the events A1, A2, AN. In total probability part, you want E to happen. E to happen in conjunction with any of n events. But here, what is the specialty and what is the significance of Bayes' theorem is, you want the event to happen, event E to happen, but event E should happen only in conjecture with AK. One among the n events. I repeat, I will try to put it in simpler way. What is this? There are n events. An event E can happen with A1 or with A2 or with A3 or with AN. But you want the probability of event E happening with any one of the AN, not with all. If it is with all, it becomes a total probability. Okay. Now we will see the proof. Okay. Now here see, first probability of E is equal to sigma I equal 1 or rather K equal 1 to n probability of AK into probability of E given AK. This is by total probability. By total probability. Right? Then next